Okay, let's learn functional programming in Python. Functional programming knowledge is critical to being a well-rounded developer. Learn the conceptual fundamentals in Python. Yes, Python. I'll be interested to see how they restrict usage of Python to just functional ways of doing things. We'll see. Should be interesting. Let's go. So I did this course years ago when it was in a different form. Because of that, it shows some of these lessons as already complete, but I'm gonna work through all of them anyway. But only the previously unfinished ones will allow me to gain experience on the platform. What's this? Oh, that's the difficulty indicator. Also, let's use an experience potion. Is that what it's called? Buy and activate potion. Let's go. Neat. Okay. Actually, I might have been able to wait until I was up to new lessons. But anyway, let's learn. What is functional programming? Functional programming is a style, or paradigm if you're pretentious, of programming where we compose functions instead of mutating state, updating the value of variables. Functional programming is more about declaring what you want to happen rather than how you want it to happen. Imperative or procedural programming declares both the what and the how. Let's see where this is taking us. Wikipedia and Wikipedia. Sure, but let's continue with the lesson for now. Example of imperative code. Car equals create car, car.addGas10, car.cleanWindows. Example of functional code. Return clean windows of addGas of create car. The important distinction is that in the functional example, we never change the value of the car variable. We just compose functions that return new values, with the outermost function, clean windows, in this case, returning the final result. Doc2Doc. In this course, we're working on Doc2Doc, a command line tool for converting documents from one format to another. If you're familiar with Pandoc, which would link to pandoc.org, if you're familiar with Pandoc, the idea is similar. Assignment. Complete the stylized title function. It should take a single string as input and return a single string as output. The return string should have both the title centered and a border added. Use the provided functions center title and add border, which we can see here, for example, center title of document returns a document with .replace. Okay. Center the title before adding the border. Do not create any variables. Use only one line of code in the function body. So we're going to be doing a return from this line. And just for ease of thinking, I'm going to move to a new line now. It says center the title before. So the first thing I'll write is center title of document. Now that's going to return something, namely another document. I think another document. So now we can add border. So I'm going to write a call to add border like this. Oops. And then I'm going to move the center title call to the inside of that. Then return that. Control Enter to run. And look, I didn't type it right. We need add underscore border, but not like that. So on the run mode, we see that one passed. That's good. Some were skipped, so we run it for real now with submit. And it's correct, but no experience because I already finished this one before. Hi, Python. Frankly, Python is not the best language for functional programming. Reasons include no static typing, almost everything is mutable, no tail call optimization, side effects are common, imperative and OOP styles abound in popular libraries, purity is not enforced, and sometimes not even encouraged. Some types are hard to define. Pattern matching is weak at best. So seriously, why are we using Python? One reason trumps all others: you already know Python. Python is a great choice for learning programming basics, OOP, algorithms, and data structures, and we don't think the trade-off of learning a new language at this point in the curriculum is worth it. We'll still be able to cover the most important concepts of functional programming in Python, even if we have to jump through a hoop or two to do it. Things like higher-order functions, first-class functions, pure functions, recursion, closures, and currying. Also, info, we plan to someday release a functional programming 2 course in a more functional language, perhaps Haskell, OCaml, or Elixir. I think the old version of this functional programming course was in one of those, but I'm not sure. But on the other hand, Python do be pretty popular. FP and Haskell, FP and Python. Okay, sure. Why learn functional programming in Python? Because we already know Python. Good reason. Immutability. In Python, we strive to make data immutable. Once a value is created, it cannot be changed. Mutable data, on the other hand, can be changed after it's created. Who cares? Immutable data is easier to think about and work with. When 10 different functions have access to the same variable, and you're debugging a program with that variable, you have to consider the possibility that any of those functions could have changed the value. When a variable is immutable, you can be sure that it hasn't changed since it was created. It's a hell of a lot easier to work with. Generally speaking, immutability means fewer bugs and more maintainable code. Tuples versus list. Tuples and lists are both ordered collection of values, but tuples are immutable and lists are mutable. You can append to a list, but you cannot append to a tuple. You can create a new copy of a tuple using values from an existing tuple, but you can't change the existing tuple. Lists are mutable. Ages equals 16, 21, 30. Ages is being changed in place. Ages.append 80. And the comment shows you what it would be. Okay, good. Tuples are immutable. Ages equals 16, 21, 30. More ages equals 80, comma. Note the comma. It's required for a single element tuple. All ages is a brand new tuple. All ages is equals ages plus more ages. Okay, that's how you concatenate tuples. Or we can even reassign the same variable to point to a new tuple. Ages equal ages plus more ages. What? Oh, reassign the same variable. Got it. Similar to how you may have seen x equal x plus 1. The add prefix function accepts 2 arguments. Document a string. Documents the current tuple of strings. It should do 2 things. Add a prefix of x dot, and I think that's 1 space. Yes, that's what we have here. To the beginning of the new document, where x is the next index in the tuple. Oh, okay. The first document should be 0, next will be 1, etc. Return the document's tuple with the new document added to the end. You don't need to write any loops yourself. The provided test code will call add prefix multiple times in a loop, gradually building up the document's tuple for you. Where do we keep track of where we are at the index, though? Run the code to see the error. I'll click it with the mouse so you can see this time. Run code. Tuple object has no attribute append. Oh, nice. They're showing us an example of that. Whoever wrote this code assumed that documents is a list, but it's a tuple. Here's documents coming into the function, and here's where they wrote documents.append new doc. Good. Fix the bug. Instead of attempting to mutate the input tuple, create a brand new tuple with a new document added to the end and return that. So let's refer back to the syntax examples above. Ages equals ages plus more ages. So on this line, can I control? No, I can't. But I can do this. I'm going to use the same variable name, and I'm going to construct a tuple from documents plus, and then just on the fly here, I'm going to construct the new shorter tuple, which is going to be new doc, comma. Let's try that. Yep, passed. So submit. Very good. CSS is typically, spoiler alert, declarative. I'm going to read instead of watching the video for now. Functional programming aims to be declarative. We prefer to declare what we want the computer to do rather than muck around with the details of how to do it. Let's take an extreme example and pretend we wanted to style a web page with CSS. Obviously a hypothetical example. Well, why would anyone want to work on the front end? This is a back-end dev course, so okay. Declarative styling. The following CSS changes all button elements to have red text. Button color red. It does not execute line by line like an imperative language. Instead, it simply declares the desired style, and it's up to a web browser to figure out how to apply and display it. What if I put Twitch chat in this terminal? That'd be kind of neat. Except we're on YouTube. Same idea. Unlike functional programming and CSS, a lot of code is imperative. We write out the exact step-by-step implementation details. This Python script draws a red button on a screen using the tkinter library, with the link being sent to docs.python.org and tkinter. From tkinter, import star. I don't love import star, but in this small example, I don't think it'll cause problems. Master equals tk. Master.geometry. Using a string in a particular format to set the window size. So that's kind of interesting. Anyway, button equals button. Called on master. Text equals submit. fg equals red. Dot pack. Dot pack is an interesting word to use there. Master.main loop. Start the event loop. Okay. CSS is typically declarative. Already answered that. A script that does one thing after another is imperative. It's math. Functional programming tends to be popular amongst developers with a strong mathematical background. After all, a math equation isn't procedural, it's declarative. Take the following math equation. Average equals sigma x over n. To put this calculation in plain English, sigma is just the Greek letter sigma. It represents the sum of a collection. X is the collection of numbers we're averaging. N is the number of elements in the collection. Average is equal to the sum of all the numbers in collection X divided by the number of elements in collection X. So the equation really just says that average is the average of all the numbers in the collection X. This math equation is a declarative way of writing calculate the average of a list of numbers. Here's some imperative Python code that does the same thing. Define get average of nums. Total equals 0 for num in nums. Total plus equal num. Return total over length nums. Not guarding against 0 length nums, but we'll not worry about that for now. However, with functional programming, we would write code that's a bit more declarative. Define get average of nums. Return sum nums over length nums. Here we're not keeping track of state. The total variable in the first example is stateful. Wikipedia, state, computer science. We're simply composing functions together to get the result we want. Assignment. In the world of document conversion, we sometimes need to handle fonts and font sizes. Complete the get median font size function. Given a list of numbers representing font sizes, return the median of the list. That's the one in the middle, right? And maybe we'll use floor division to, to handle when there's an odd number. 1, 2, 3. 2 is clearly the center, so we get 2. 10, 8, 7, 5, get 7. Notice the second list of out of order. Sort the list so that it is in ascending order. Then find the middle index and return the middle number. If there is an even amount of numbers, return the smaller of the two middle numbers. I know that's not a true median, but good for our purpose. Would a true median take an average of the two middle numbers? Maybe. If the list is empty, just return none. Here are some helpful docs. Sorted. Ah, yes, they prompt us to use sorted, which is good in a functional context. LEN for length and double divide for floor division. To be a good little functional programmer, your code for this lesson should not use loops, mutate any variables. It's okay to create new ones. This requirement, don't mutate any variables, is why we won't do dot sort. We will instead do sorted. I'm wondering whether to use a new variable. I'll use the same variable name. Equals sorted on font sizes. Font sizer. Oops. Sizes. And I guess I'll use a variable for length. Font sizes. Font, please. We'll be using length divide by 2 floor division. If there's an even number of numbers, return the smaller of the two middle numbers. So for example, in this case, wait, let's floor division will automatically give us the smaller one, right? I'm pretty sure it will. It's at ended up typing that twice. Well, I made an assumption that didn't pan out. What input caused that to happen? Ah, I was complaining before about not guarding against zero length, and here I... So how'd that happen? Yeah, length was 0. 0 divided by 0, floor divided by 2, still 0. But addressing index 0 on an empty list not going to work. So does it tell me what to do? If the list is empty, return none. Okay, we'll just add a check for that. Definitely check that before the sort. What would happen if we sorted the empty list? Probably just return another empty list. If length, font, sizes equals 0, return none. And otherwise it continues. And now let's try that again. 3 passed, 1 failed. Is this an edge case problem? I think it's an edge case problem. 9. Oh, look at that. They sorted the input to make it easier for us to see. 9, 11, 16, 20. Expected 11, actual 16. I'm going to have to actually think about this one. Okay. It's going to be length equal 4. Length divided by 2 equals 2. Ah. I see the problem. Nice of them to include a test that catches this error in the run group and not only the submit group. So it says, if there's an even amount of numbers, return the smaller of the two middle numbers. I know it's not a true median, but good for our purposes. In contrast, when we had let's play out another example here, just for demonstration purposes. We had, I'm going to sort it now, 14, 16, 20. I see why I had problems with my assumptions. 3 divided by 2 would be 1.5, but it rounds down, right? Does it round down? Let's just check that. Um, 3 divided 2. Yeah. So 0, 1, 2 puts us in the middle. But in this case, 0, 1, 2 put us on 16, but I wanted the first of those. And I'm overthinking this, but I'm trying to think of the most straightforward and like usefully meaningful. Well, we'll just say do I truncate it before or after the division? I actually have to truncate it. I have to check before the division because we lose information otherwise. Right? Like watch this. I have examples that are length 3 and 2. Let's look at the division of both of those by 2 with floor division. Or let's also look at 5. Once we have the result of the division, it's 2, whether it was 4 or 5. So we have to check the evenness case before we divide. If length mod 2 equals 0. We could subtract 1 here, which feels a little hacky, but let's try it. And now we pass. Yeah, because but I'm not okay with subtracting 1 from length and calling it length, so let's use a different. Should I use like effective length? Am I overthinking this? I might be overthinking this. It's interesting how we could subtract 1 at either. Anyway, I'm overthinking it. I'm just going to do it like this, but after I submit it, I'll see their solution to see how they chose to handle the if-even logic. So I've already submitted it, so now I don't feel bad looking at the solution. Oh, they subtract 1 in all cases. I guess you could do that. Huh. Huh. If it was an even number like 4, it would go down to 3. If it was an odd number like 3, it would go down to 2. But that would have been thrown away in the remainder or in the floor division anyway. You can see that here. 3 divided by 2 is 1. If we subtract 1, we get 2. 2 divided by 2 floor division is still 1. Huh. That is interesting. Okay, let's move on. Classes versus functions. I run into new developers who, after learning about classes, want to use them everywhere. They assume that because they learned about functions first, functions are somehow inferior. Nope, they're just different. Why are we talking about classes versus functions now? Well. Also, what do classes mean in a functional context? Aside from them just being a different word than function. Should I use functions or classes? Here's my rule of thumb. If you're unsure, default to functions. I find myself reaching for classes when I need something long-lived and stateful that would be easier to model if I could share behavior and data structure via inheritance. This is often the case for video games, simulations, GUIs. The difference is classes encourage you to think about the world as a hierarchical collection of objects. Objects bundle behavior, data, and state together in a way that draws boundaries between instances of things like a chess piece on a board. Functions encourage you to think about the world as a series of data transformations. Functions take data as input and return a transformed output. For example, a function might take the entire state of a chessboard and a move as inputs and return the new state of the board as output. Side note, I remember seeing some meme code that had like print and then text characters representing a tic-tac-toe board, and then if input equals X, print, and then a representation of a tic-tac board with the X placed, somewhere. I don't remember all the details, but it was good and silly. Use whatever feels right to you in your projects and adjust and refactor as you improve your skills. Which is better? They're good in their own special ways. 8. Which encourages you to break down problems into instances of stateful things, classes. 9. Debugging functional programming. Okay, debugging FP. It's nearly impossible, even for tenured senior developers, to write perfect code the first time. That's why debugging is such an important skill. The trouble is, sometimes you have these elegant, sarcasm intended, one-liners that are trickier to debug. Readability counts. Anyway, define get player position, position, velocity, friction, gravity, return. Calc gravity of calc friction of calc move of position, velocity, comma, friction, comma, gravity. Oof. Oh. Yeah, it's not very easy to reason about. If the output of get player position is incorrect, it's hard to know what's going on inside that black box. Break it up. Then you can inspect the moved, slowed, and final variables more easily. Define get player position, position, velocity, friction, gravity. So same signature as we started with above, but now moved equals calc move, position, velocity. Slowed equals calc friction of moved and friction. Final equals calc gravity of slowed and gravity. Print given position. So these are the initial things. Results moved, slowed, final. Return final. Once you've run it, found the issue, and solved it, you can remove the print statements. Yep. Print statement debugging. Assignment. Fix the format line function. Why do we have a commented out return thing here? It should apply the following transformations in order. It should strip white space from the beginning and end of line, capitalize every character in the line, remove any periods in the line, append an ellipsis to the end of the line, words go here. Run the code. You should see that some subtle bugs are present. Break up the function to make it easier to debug. Use print statements to see what's going on at each step. I'll click run to show what's happening. 3 passed, 0 failed. I'm surprised that none failed if they said there were bugs, but I guess the run tests didn't detect the bugs. 3 passed, 0 failed, 1 skipped. I'm tempted to peek at the test cases to get a hint at what's wrong, but let's think about this from here. Why is there a commented out here? maybe this was like maybe they are implying that it used to be this way, and someone refactored it to here. Anyway, it should apply the following transformations in order. Strip white space from the beginning of the line. I believe that's what strip does. Capitalize every character in the line. Stripped.upper. Looks good. Remove any periods from the line. Remove.replace period with empty string. Add an ellipsis, dot to the end of the line. Words go here. Remove plus dot dot dot. Return suffixed. I'm missing something. Look at the tests. Well, unless this has already the solution that I did from years ago, is that possible? And as far as experience goes, I've already solved it, so it doesn't matter if I submit a wrong answer. Let's reset the lesson and see if it's like, if it remembered my solution from years ago, which would explain my confusion. Yes, reset progress. Okay. I should have copied my solution before I reset the lesson. Darn it. Line dot, R strip. That's one of the problems. Capitalized or replace. Is that the whole problem there? No, there's something else. Well, whatever. Functional versus OP. Functional programming and object-oriented programming are styles for writing code. One isn't inherently superior to the other, but to be a well-rounded developer, you should understand both well and use ideas from each where appropriate. You'll encounter developers who love functional programming and others who love object-oriented programming. However, contrary to popular opinion, FP and OP are not always at odds with one another. They aren't opposite. Of the 4 pillars of OOP, inheritance is the only one that doesn't fit with functional programming. Encapsulation, abstraction, polymorphism, and over on the side, inheritance. Cool. Inheritance isn't seen in functional code due to the mutable classes that come along with it. Encapsulation, polymorphism, and abstraction are still used all the time in functional programming. When working in a language that supports ideas from both FP and OOP, like Python, JavaScript, or Go, the best developers are the ones who can use the best ideas from both paradigms effectively and appropriately. Functional and OOP programming are about writing cleaner code. What were the other ones? Faster, less memory, any machine. Okay. OOP's concept of inheritance conflicts with functional programming because of the mutable values. Statements versus expression. Oh, I don't know if I want to do an interview with AI right now. Statements versus expressions. Studying functional programming is really about returning to the most basic aspects of programming and looking at them in a new way. Statements and expressions are a great example of that. Statements. Statements are expected to be carried out. For example, set n to 7, define a function named greet. If x greater than 10, print a greeting to Alice. In Python, such statements look like this: n equals 7, variable assignment statement, define greet name, return hello name. If x greater than 10, print greet Alice. I don't see the logical connection between 10 and Alice, but moving on. For I in range n, print I. Every complete instruction is a statement. Expression. Expressions are a subset of statements that produce values. Evaluating an expression results in a value that can be used in whatever way is needed. It can be assigned to a value, returned from a function, etc. Result equals 2 plus 2. Well, 2 plus 2 is the expression, right? Because result equal would be the statement, yes? Yeah, n equals 7. Return length hello. Function call expression. Cost, total cost equals length items times cost. One thing that may surprise you is that in most languages, including Python, every function call is an expression, right? When you call a function, it returns a value, whether or not you realize it or do anything with that value. Even if a Python function doesn't have a return statement, it still implicitly returns none. You can test this by assigning a print call to a variable. Well, that's silly, but let's do it anyway. X equals print quote hello. I don't think I've done this before, because it feels weird. But anyway, print X. And now we see the none that returned from print. Good. Sure enough, print, the first function that we all learned, technically returns a value. Expressions over statements. Because expressions always produce values, they're reusable and declarative. You can compose expressions and nest them within each other, but you can't always do that with other kinds of statements. Functional programming encourages the use of expressions over statements where possible. Backing up to that, so none of these will return anything? I mean, functional programming encourages the use of expressions over statements where possible because expressions tend to minimize side effects and make code easier to reason about. For example, a function that returns a sum is an expression. Total equals sum of this. We can get the same result with a loop, but that involves a series of statements. Total equals 0 for n in these. Total plus equals n. Again, it's simple to combine expressions, print sum of those times 2. But we can't really do the same thing in our series of statements. This doesn't work. Print total equals 0. Yeah, that doesn't make any sense. Chatter says hi. Hello, Chatter. For n in that, expressions tend to be concise and logically pure. Some languages that are designed for functional programming, such as Haskell, actually treat everything as an expression. In these languages, even control, flow, constructs like if and else are expressions that return values. I wonder how that works. Let's make a note of that. Note for later. How does Haskell treat constructs like if and, oh, not else, that's a case, as expressions? I don't want to do an interview with Boots right now. I'm just going to jump forward. Although I will read the prompt or the question. Are they prompting me? I think they're prompting me. What makes expressions rather than other kinds of statements especially useful in functional programming? Ternary expressions. Ternaries are a great way to reduce a series of statements like an if-else block to a single expression. Okay. When you first learned how to use conditional logic in Python, it probably looked like this. Result equals 0, if number mod 2 equals 0, result equal number divided by 2, else result equals number times 3 plus 1. Why would you ever want to do that? This code sets result to a dummy value like 0. None would also work. Then overwrites its real value based on the condition. A ternary lets us do that in one expression. Oh, I kind of skimmed past the result equals 0. Wasn't that interesting though. Anyway, result equals number divided by 2 if number mod 2 equals 0, else number times 3. Can't quite see it, but I assume it says plus 1 there. Yeah. Note, we also avoided mutating the result variable. Oh, I know why they had to set result equals 0 up there, so that it would be in scope in case I needed it down here. Yeah, that makes sense. We have a chat from I Try Hard, good username, asking, hey, what is this live about? This is learn functional programming in Python from Boot.dev. A ternary lets us do all that in one expression. Yeah, I read that. Note that we avoided mutating the results variable. Right. We did the expression. We saved it to a variable. I feel like the explanation above was a little bit loosey-goosey on assignment statement versus an expression on the right side of an assignment statement. But I guess it doesn't make much sense to write the expression bare on a line because that wouldn't do anything. Anyway, the syntax for a ternary in Python is, there it says, are you learning or teaching the course? They're a bit confused over here. Some at column A, some at column B. I went through this course a couple of years ago when it was in a different form. And I've had some spare time on my hands recently, and Boot.dev is running a thing where you get a Resolute badge if you complete lessons every day in January. So I started studying that again, and I enjoyed the gamification. And I felt like being social and sharing and content creating about it. But I think this particular course will be fairly easy for me. It's stuff that I should mostly know. The syntax for a ternary in Python is value A if condition else value B. This qualifies as an expression because it's a single statement that evaluates to a value, one of two values depending on the condition. When to use ternaries. Ternary expressions are cool, but don't overdo it. If you're dealing with complex conditional logic, it's often easier to work with if-else blocks than to try to nest ternaries inside of each other. Ooh, gross. Why would you nest ternaries? Message equals access granted if user is authenticated and user.role equal admin, or user.role equals editor, and not user.suspended. That implies that a suspended admin would be able to access, although I guess maybe the point of being an admin is that you can't be suspended. I don't know. Else access limited if user.is authenticated, else access denied. That's a little brain melting. Hey, going on? Oops. Assignment. Our doc-to-doc utility is designed to accept input documents in a variety of formats. It chooses the appropriate parser for a document based on the extension of the file name. Currently, only Markdown and plain text parsers are supported. Fix the choose parser function. The logic is correct, but we want to simplify the conditional block to a one-line ternary expression. Okay, let's scroll back up and review the syntax of a ternary expression. Value A if condition else value B. I'm glad that it doesn't have like a question mark and a colon, like you see in some languages. Return. Mark down. If, and rather than typing all this, file extension, oh, it's either .markdown or .md, sure. Else, and we have plain text here. Okay. Yeah, that checks out for me. Submit that. And look, we gained experience that time, so that's nice. This one we've already finished, but I'll still do it again. Function practice. Doc2Doc should seamlessly convert hex triplet color codes to RGB values. Hex colors are an efficient means of representing color with only 6 characters. RGB values combine red, green, and blue light to electronically display the entire color spectrum. Assignment. Debug the hex to RGB function. Now, does this have my solution already here? No, it doesn't, because I left a question mark. Or I wouldn't have left the question mark comment there. Yeah. Debug the function. Hex to RGB should take a hex triplet color code and return 3 integers for the RGB values using int. 0 up to 2, but not including 2 to 4, 4 to end. That looks okay. One of the arguments used in int is incorrect. Examine the documentation to see how to convert hexadecimal values. Ah, hexadecimal. It's about the base. Use the provide is hexadecimal function inside of a hex to RGB to check if it is valid. If the input is not a 6-character long hexadecimal string, raise an exception, not a hex color string. Example: red val is print red val 160. Okay, we're taking it to base 10, so we need to. Well, I'll follow along with the instructions like it says. We'll go to docs.python.org, move over here. Class int string base equal 10. Class int of number equals 0. Return integer object constructed from a number or a string. Oh, the number could be like a float. I guess that's what that's for. Okay. But when it's from a string, we need to specify where we can specify a base. We need to specify 16 because it's hexadecimal. And I made some error. Let's find out what. Don't edit below this line. Use the provide is hexadecimal function inside of hex to RGB. Oh, that's what this was for. Okay. If the input is not a 6-character long hexadecimal string, raise an exception. Yeah, okay. Just a generic exception? Probably. If not, is hexadecimal of hex color. Then we... Ooh, typing, what? Then we raise an exception of not a color string. Type it again, not a hex color string. We're still not quite there. Which one failed? Assignment. Let's read the assignment again. I'm sure I'm just not paying attention to the instructions. Debug the hex to RGB function. Hex to RGB should take a hex triplet color code and return 3 integers for the RGB values using int. One of the arguments to int is incorrect. Examine the documentation to see how to convert these hexadecimal values. Use the provided is hexadecimal function inside of hex RGB to check if its input is valid. If the input is not a 6-character long hexadecimal string, raise an exception, not a hex color string. Oh. I see. This validates whether it's a hex string. I also have to check whether the length is wrong. And I think the length calculation will be less expensive, so let's do that first. No, we're still not there. Wait. What type is hex color supposed to be? You gave me an int? Inputs 42. Expected error, not a hex color string. Pass. Inputs. No, this looks like a string. Expected error, not a hex color string. Actual error. Object of type int has no length. Show me what this is. Oh. You did give me an int. Why would you give me an int? Well, let's just do another not here. Not type of hex color. Okay. Got him. Now into what I believe is new content for me. Also, let's clear and echo hello Jamal. Functions as values. In Python, functions are just values like strings, integers, or objects. For example, we can assign. Also, this chapter is first class functions, so good. For example, we can assign an existing function to a variable, def add xy return x plus y. Assign the function to a new variable called addition. It behaves the same as the original add function. Addition equals add. Print addition of 2 and 5, we get 7. Good. With the popularity of generative AI like ChatGPT, we need to be able to convert files into pure text to be injected into prompts. Okay. Complete the file to prompt function. It should take a file dictionary and a toString function as inputs and return a formatted string. Call the provided toString. Provided, I don't see a toString function with file as an argument. Oh. I guess the test must provide a file class that has a toString function or method on it. Let's take a look at that. Oh, it's just a function. And it returns that's a pattern I haven't used before, but we use the parentheses to group things, and although these that's interesting. It's going to concatenate these strings, and they have new lines at the end, which are distinct from the new line in the source code. Okay. So we'll get a string out of that. Call the provided toString function with file as an argument. The function is responsible for converting the file dictionary into a string. You don't need to implement it. And then wrap the toString function in triple backticks to format it as code in Markdown. For example, an example string should become an example string like this with new lines. And we can return that, right? Let's try this syntax trick that we learned from the test suite, where we start with a yeah. I won't use f strings because I don't need to do variable content. We do the 3 ticks, and the new line. And that'll be concatenated with the string result of that. I think this is allowed to be done. and then another new line, and the 3 ticks. This feels weird. I don't know if it's going to work, but let's try it. Okay, I don't understand that fancy syntax, so let's just do it in the way that would be natural to me. Maybe because it wouldn't have known that this was going to be a string. It couldn't. Yeah, that trick probably works with all string literals. I could have done an F string, but whatever. Okay. Hey, we get the celebration. Very good. Anonymous functions. Anonymous functions have no name, and in Python they're called lambda functions after lambda calculus. Here's a function that takes a single argument x and returns the value of x plus 1. The result of x plus 1. Increment. Lambda x colon x plus 1. Note that the expression x plus 1 is returned automatically. No need for a return statement. And because functions are just values, we can assign the function to a variable named add1. It's not so anonymous if we name it. Add1 equals lambda x colon x plus 1. Not going to do that now. Add1 equals lambda x plus 1. Add1 of 2 is 3. Lambda functions might look scary, but they're still just functions. Because they simply return the result of an expression, they're often used for small, simple evaluations. Here's an example that uses a lambda to get a value from a dictionary. Get age equals lambda name colon dot get name comma not found. Oh, okay. So you define the lookup dictionary inside the lambda function. That's interesting. I mean, print get age of Lane, you get 29. Assignment. Complete the file type getter function. This function accepts a list of tuples where each tuple contains a file type, e.g. code, document, image, etc., a list of associated file extensions, .py, .js, or .doc, or .x, or .doc. The function returns a function for looking up the file type of a given file extension. Create an empty dictionary to map each file extension to its file type. Now I would say D equals dictionary syntax, but I think it's going to end up being an expression in the lambda function, so I won't do that. Loop through the file extension tuples. Loop. How would you write a loop in a lambda function? Well, to help me, at least help me reason about this, let's write it this way. For file extension tuple in file extension tuples, loop through the file extension tuples, loop the file extensions, add each extension to the dictionary and assign its value to the file type. So file type, comma, list of extensions equals file extension tuple. We're unpacking it there. Now for extension in list of extensions, D at add each extension to the dictionary and assign its value to the file type. So the key is the extension. No, the key is the file type. loop through the file extension tuples, loop to the file extensions, add each extension to the dictionary and assign its value to the file type. Okay, I got that exactly backwards. For example, if given the following list of tuples, documents.doc and .docx, image.jpeg.png, resulting dictionary .doc document .docx document. Yeah, that's what I did here. The key extension, value file type. 3, return a lambda function that accepts a string, a file extension. 2, and returns its file type from the dictionary, and we'll do d.get of file extension and return unknown if it's missing. That should work. Okay, submit that. First class and higher order functions. A programming language supports first class functions when functions are treated like any other variable. This means functions can be passed as arguments to other functions, can be returned by other functions, and can be assigned to variables. First class function, a function that is treated like any other value. Higher order function, a function that accepts another function as an argument or returns a function. Python supports first class and higher order functions. First class example, def square of x, return x times x. Assign a function to a variable f equals square, print f of 5, 25. Good. Higher order example, define square of x, return x times x. Define my map of func arglist, result equals list. For I in arglist, result.append func I, return result. This one jumps out as feels like new from what we've seen so far. I assume they'll go into more detail into this type of situation later. Anyway, define my map of function and arglist. Result is empty list. For I in arglist, okay, we iterate over the arguments. Result.append func, we apply the function to argument I. Okay, yeah, that's why it's a map. Return result. Squares equals my map of square 1, 2, 3, 4, 5. Print squares 1, 4, 9, 16, 25. Got them. What is a function that returns another function? That is the higher order function. Is this the yeah? Which is the higher order function in the second example? That is my map, which here returns squares, which is a function. No. Wait. Or returns a function. Okay, higher order function, a function that accepts another function as an argument or returns a function. In this case, my map is it accepts a function. Map, filter, and reduce are 3 commonly used higher order functions in functional programming. In Python, the built-in map function, that's why we had to use my map before, takes a function and an iterable, in this case a list, as inputs. It returns an iterator that applies the function to every item, yielding the results. Dale Cooper, add hello, hello Dale Cooper. All these people, all these hellos. With map, we can operate on lists without using loops and nasty stateful variables. Okay. For example, given this code, Define square of x, return x times x. Nums equals 1, 2, 3, 4, 5. Squared nums equals a list. We're going to end up mutating that list. For num in nums, num squared equals square of num. Num squared nums dot append num squared. Print squared nums and we get the result. We could use map instead like this. Define square x the same way. The numbers and squared nums equals map square onto nums. Print the list, we get the same result. Info. Map returns a map object, so the list type constructor, oh yeah, we did that here, is needed to convert it back to its standard list. We'll just gloss over that for now. Assignment. Markdown supports two different styles of bullet points, dash and star. We prefer star, so we need a function to convert any dash bullet points to star bullet points. We'll have to detect like if they're at the beginning of the line, right? Complete the change bullet style function. It takes a document as a string as an input and returns a single string as an output. The returned string should have any lines that start with a dash character replaced with a star character. For example, this is a bullet, this is a bullet, becomes bullets but with stars. Use the built-in map function to apply the provided convert line function to each line of the input string. Convert line, okay, that's the logic. We convert the line. Use dot split and dot join to split the document into lists of lines and then join the lines back together. This should preserve the original line breaks. If we split on new line and join with new line, that'll work. Oh, we've got a chatter. Hello, chatter. Is that Sean Megison? Welcome in. Thank you. Don't use the dot replace string method. Okay. Examples of split and join. This should preserve the original line mix. Don't use dot replace method. Lines list equals my document dot split new line. Rejoin doc equals new line dot join. Yeah, that's what I was thinking of doing. So lines equals document dot split on the quote new line. And like if we use the same variable name, lines equal, let's review the syntax above. What's there an example above? Yeah. Squared nums equals map square to nums. And you know what? I'll give it a new variable name. We'll call it processed lines. Equals map of convert line onto lines. And then we can say, I'm being a little over verbose here, but we'll do it. Processed equals new line string dot join of processed lines. Return process document. We have a chat. Sean Megison asks, is functional programming like HTML? It looks like HTML. So the right screen to design a website, is it to do so? Well, the right screen, I think by right screen you mean this. I don't really need two screens for this. Let me see if I can understand your question a little better. Is functional programming like HTML? I don't think it's a lot like HTML. You could talk about using a function to parse the HTML and create a web page, to display visually a web page. The right screen, it looks like the HTML on the right screen. Do you mean this? I mean, this isn't, I don't see any HTML over here. This is, I mean, yes, there's HTML in the source of this page, but this is Python, this is text in Python. Over here is a shell command just to echo hello functional. So nothing really looks like HTML to me here. As for the question of if HTML, is it hard to learn? It takes sustained attention, and it takes practice and consistent actions to test your assumptions and probably correct them. It also takes typing carefully, or you'll get errors like name error, name convert line is not defined. Did you mean convert line? Sometimes you can read the error messages and they point you in the right direction. Yeah, thank you. So convert line, what line did I do that on? Line 3. Yeah. That'll be better. 2 passed, 0 failed, 0 skipped. Now we submit. And just to demonstrate, the reason I have this window open is I can do things like echo note to self, Python map syntax, and then I could remember that the syntax is with a tick for code, map of function to apply, and I'll use nums as for an example here. Now I have that over here to remind myself. Yesterday I was using the terminal to write code and submit it to the web page according to instructions on this Boot.dev web page. But today I just left it up and I'm using it for my own notes. Filter. The built-in filter function takes a function and returns an iterable, in this case a list, and returns an iterator that only contains elements from the original iterable where the result of the function on that item returned true. Is Palmer, filter. Dale Cooper is not Palmer, but Laura Palmer is Palmer. So it gets through. In Python, define is even, return x mod 2 equals 0. Numbers is 1 through 6. Evens equals list.filter with is even function on numbers. Print evens 2, 4, 6. Good. Thanks. You have a good one too. Complete the remove invalid lines function. It accepts a document as input. It should. Use the built-in filter function and a lambda to return a filtered copy of the input document. Remove any lines that start with a dash character. Keep all other lines and preserve any trailing new lines. I feel like I'm going to want to do some work outside of the filter call, but let's see the example. Star Wars Episode 1 is underrated. Star Wars Episode 9 is fine. Star Wars Episode 3 is the best. Episode 3? Moving on. I'm going to do remove any lines that start with a, I'll use an is valid line function and I'll apply it on lines. Now I'll need to define both of those names. And a lambda. Maybe the lambda is supposed to go here. Anyway, lines equals document dot split on quote new line. From line to remove the lines that start with it. So I think I can do not line at space 0 equals that. We apply that to lines, and now we return. We're going to reconstruct that into a document. New, oops. Quote new line dot join on lines. Except I made a mistake, because what I really need to do is say that filter returns something. I'll assign that to filtered lines. And let's try that. Run that. Fail. Did I get it backwards? Input document. We are the music makers, and we are the dreamer of dreams. Come with me and you'll be... Expected output. We are the music makers, come with me and you'll be... Actual output. Oh. Typo. I'm checking lines here. The 0 index element of lines will be a list, which will never be, and a list will never be equal to the string here. A statically typed language might have caught that problem for me. We'll delete the S and try it again. We have empty lines. Let me check the test input. Oh, maybe I'll have it here. Oh. So I might need to guard it with a... Because the problem is with that empty line, wait, what? Input documents. Anyway, I think it's a problem. I know it's a problem with an empty list because it's saying line 0, string index out of range. The only way that could happen is with an empty string. So maybe this is a good place for a ternary statement. I need to check if it's... Let's start by writing this down here. Length of line equals 0. Wrap that in a parens. And in this case, in the case where length is 0, we want to return true. So it I think this is my fix. Because this will short circuit the OR. Okay. Run that. There we go. Let's submit that. Let's see. Am I going to finish this chapter tonight? I don't think I'm going to finish the whole course tonight. I don't even know if I'll finish this chapter tonight. Let's keep going for now. First class function, reduce. The built-in functools.reduce function takes a function reduce. It's like a running sum, for example, I think. And a list of values, and applies the function to each value in a list, accumulating a single result as it goes. Before that we did filter. I'll just echo filter. Reduce of concatenate words list. Just keep swimming, exclamation point. Just keep swimming, exclamation point. Yay. Import, oh, we need to import functools from the standard library. Does this web page preload the standard library? Huh, interesting. Import functools from the standard library, import functools. This is an example. Define add sum so far x, print sum so far x, return sum so far plus x. Numbers equals 1, 2, 3, 4. Sum equals functools.reduce add comma numbers. I'm getting tired. I am getting tired. 10 doesn't print, it's just the final result. Print sum. Wait a second. Did you just shadow the built-in name sum? That's not so good. Notice that we are passing the function add without the parentheses. Yeah, because we're not calling it when we're passing it. It means that reduce will take care of execution and pass the parameters for you. Yeah, just like filter did before. Think of passing add like handing someone a recipe, the instructions, instead of the finished list, the result of the execution. Assignment. Complete the join and join first sentences functions. Complete the join function. It's a helper function we'll use in the join first sentences. It takes 2 inputs. A doc so far, accumulator string, similar to the sum so far variable in the example above. So like a string that starts as empty string. A sentence string, this is the next string we want to add to the accumulator. So we'll just concatenate them, right? A sentence string, return the result of concatenating doc, and sentence. Do we need to like put a space in here? With a period and a space in between. Like that. Yeah. That's looking good. Complete the join first sentences function. It accepts 2 arguments. A list of sentence strings. That's the sentences. An integer n. What's the n for? Only use the first n sentences from the list. Okay, we're accumulating only up to a number. If n is 0, just return an empty string. Let's take care of that first. Use functools.reduce with your join function to combine the sliced sentences into a single string. And what is the usage for reduce? We had it above here. Add common numbers. Is it going to take a default starting point? Probably. This is with join on sentences. Add a final period without a trailing space and return this string. Use list slicing to get the first n sentences. I almost forgot about that. I'll use list slicing in the call to reduce, going up to, if it's the first 5 then it'll be indexes 0, 1, 2, 3, 4. So we're good, just like this. Here's an example of expected behavior. Let's just run this. Yep. Map, filter, and reduce review. Echo reduce. Allow us to avoid higher order functions like map, filter, and reduce. Allow us to avoid stateful iteration and mutations of variables. Take a look at this imperative code that calculates the factorial of a number. Factorial calculator. Nice. Define factorial of n, a procedure that continuously multiplies the current result by the next number. Result equals 1 for i in range n, for i in range 1, n plus 1. Result times equals I. I feel like we could have done without the 1 here, but it's okay. Here's the result. Here's the same factorial function using reduce. Have to scroll over. But you get it done in one line, so that's something. Import functools. Define factorial of n, return functools.reduce lambda x y colon x times y, range 1 to n plus 1. Range is a generator. It'll give us like 1, 2, 3, 4. And we multiply each one. Multiply. Okay. In the functional example, we're just combining functions to get the result we want. There's no need to reassign variables or keep track of the program's state in a loop. A loop is inherently stateful. Depending on which iteration you're on, the I variable has a different value. Is there any way to break that? I mean, for I in range, so that it only goes through it once, but even on that one iteration, it has a state, so yeah. Which is the imperative way to apply changes to a list of items? A function. Imperative. Got ahead of myself. A function would be the functional way. The imperative way would be a loop. Yeah, okay. How much armor do I have now? 11. Yeah, we're doing pretty good. What is the primary advantage of composing functions instead of using loops? TJ will finally be proud of you. Well, that would be nice. Performance, composing functions is faster than loops. I would say not necessarily. Avoiding stateful mutations, which can be harder to debug and reason about. There we go. Ooh, zip. The zip function takes two iterables, in this case lists, and returns a new iterable where each element is a tuple containing one element from each of the original iterables. A equals 1, 2, 3, B equals 4, 5, 6. C equals list of zip of A and B. Print C 1, 4, 2, 5, 3, 6. Like 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. It's like a zipper. It combines them. Complete the paired document with formats function. Don't edit above this line. It takes two lists of strings as input. We have doc names and doc formats. Zip up the list. Zip doc names doc formats to a single list of tuples with the names as the first index and the formats as the second index in each tuple. That's our iterable. Filter the list of tuples to only include tuples where the format is one of the given valid formats. So we could do a lambda format to format in valid formats. That's our function. It's a lambda, and then the iterable is here. We don't have to list it. It'll do the iterable thing. Return the result as a list. So return list. At this point, we do need to cast it as a list. Fail. What did I do? Inputs, proposal, invoice, contract. I think I see the issue. No, I don't think I see the issue. I actually need to go from the doc tuple to doc tuple 0 because no, doc tuple 1 because the 1 index will have that. Now we pass, now we submit, now we're good. Higher order functions practice. Doc to doc needs a way to restore documents from saved backups. However, not all original documents may have backups, and some backups might be corrupted. Assignment. Complete the restore documents function in one line, if you can. It takes 2 tuples of document, one line if you can. It takes 2 tuples of document strings, originals and backups, and as input it returns a set. Convert all documents that are corrupted strings of random numbers with isDigit. Does that work on longer strings that are all digits? Let's just check. Click on that. Python 1 2 3 4 5 3 2 1 dot. What is it? isDigit. Okay. And if we do 1 2 3 A 3 2 1, it would say false. So I think we're relying on it to give us something with all digits. So filter document originals and backups. Wait, convert all documents to the same case with .upper for comparison. So we're going to end up doing a originals.upper, and we're going to do a backups.upper. Filter out documents that are corrupted strings of random numbers with isDigit. Are we going to be zipping this? Return a set that combines and duplicates and deduplicates the documents from originals and backups. Do we have to call the filter twice? Maybe. Lambda doc colon doc, that is, except it's going to be the inverse of that. We can optimize this, can't we? Maybe. Return set dot add I think this is it. Oops. Why is that on a new line? There we go. Let's run that. Oh, well, that's not good. Error. Filter expected to arguments got 0. Well, that's my mistake. Expected to arguments got 0. Which... Oh, well. Yeah, that's not going to help. Okay, let's read this again. Complete the restore documents function in one line if you can. It takes 2 strings of 2 tuples of document strings, originals and backups, and as input returns a set. What did I call .upper? Oh, we should map. So instead of originals.upper, we should map upper This is a nasty, nasty line. Map let's see if I got that right. Name upper oof. str.upper. None type has no attribute add. Where am I adding something? Oh, the set can. It doesn't make sense to call set and do a dot add. So instead, what I'm going to do is call set and do a, instead of add, I'll do a comma here. Set of a tuple of, let's see where this goes back to. Where does it go back to? Here. So we need to add at least one more. That might be it. Set expected at most one argument, got 2. Okay, my parentheses are not right. Where does this one close? Should not close there. It should close over here. Try that. Well, we actually got something. That's progress. So the filter object. Why didn't it execute the filter? Let's start taking this apart. Make sure things are doing what you expect them to. This might just be a map object. Yeah. But we can do list of Did I cut this out or did I copy it? Ooh, I'm losing context. Okay, I did that there. The filter carries it to, oh, no, my parentheses are still wrong. Or are they? No, they're okay. Let's see how this one does. This should be right, I have to call list on the, That's interesting. Yeah, adding the filter object to the set was not doing the right thing. So add a to each of the filter objects and see where this closes. Close that. And list of Why is there a parenthesis here? Let's take it away. Take away one of these. List of filter of, and go to the end of the filter and add a parenthesis. Try this. Well, it's not going to work if I leave my debug code in. Lister. Uh-huh. I'm not using the set, right? Convert all documents to the same case with upper for comparison. Filter out documents that are corrupted with strings of random numbers. Return a set that combines and deduplicates the documents from originals and backups. This is maybe not what I'm supposed to do, but can I just unpack the list and unpack this list? Hey, there we go. Now, can I tidy this up though? Because here we're doing a list filter. This is maybe going to get ugly, but let's try it. Set on an unpacked list containing a map of lambda docs to filter this stuff. Docs. No. Lambda from doc to this thing. And that map is applied onto a tuple of originals backups. Oof, this is, I don't know about this. Yeah, we're not quite there. Just need to move one parenthesis. I feel like that's all we have to do. Ooh, it's hard to keep track of all this. Let's just follow an instinct and move that parenthesis out there. No, that's not it. Map string.upper. Okay, yeah, I know this is bad. Lambda doc filter lambda doc not dot digit onto a map of. Okay, yeah, the problem is with originals here. Darn it. Let's rewrite it from the inside. Map some lambda onto a tuple map string.upper onto you know, we can combine originals with backups whenever we feel like it. It doesn't actually matter. So we can just do combine originals and backups here. And that's going to return iterable, and then we filter lambda doc dot is with, and then this goes in here. Set of onpack list of the following. Simplified it a bit there. I hope this is right. Do return. Whoa. We need a not, right? Not is digit. Set expected at most one argument got 4. How did I? How do I do that? Which one of these worked? It was this one. Onpack list of filter of lambda doc not doc dot is digit. And here we have map string.upper onto let's check this. Maybe I need to resolve that as a list too. Not sure why, but let's try it. But can I mud this out? Did something change so that I don't need the unpacking? That's interesting. What's happening here? And if we do list, what? Huh. I must have added an additional layer of iteration somewhere that I had to undo somewhere. Anyway, I think this is my final answer. Return a set of the list, which is filter lambda doc on a map of string on upper on originals plus backups. And we've got some stray spaces here, so let's take those out. Run. Okay. Should be good now. Let's submit. Sweet XP. You've earned a sharpshooter chest. Achievement earned. Complete 21 sharpshooter sprees. Nice. And that'll do it for tonight. Mark these as red. I'll come back to them later. Let's preview the next part of the lesson, but other than that, call it a night. Pure functions. Ooh, pure functions are a good one. But that's enough for now. Exit Python. Actually, I'll use Python to print goodbye world. Oh, hello, chatter. Jake Tastic says Happy Wednesday. Wednesday? Where are you? Anyway, I am tired. It is late. I finished 2 chapters of this. I thought I might do more today, but I've done 2 chapters. And call it a night. Thanks for watching.